The hybrid workforce is here to stay, and it requires real-time visibility, control, and rapid response of every endpoint, whether it's in the office or home. Tanium offers an endpoint management and security platform built for the most demanding IT environments. Many of the world's largest and most sophisticated organizations, including nearly half of the Fortune 100, rely on Tanium to deliver unmatched endpoint visibility and control. Whether you're preparing for zero trust or protecting your network from supply chain risk, Tanium empowers technology leaders to achieve greater agility, efficiency, and confidence. Learn more at securityweekly.com/Tanium. Today's networks are changing fast, and employees, devices, and infrastructures are more distributed than ever. Gigamon Threat Insight is a cloud-native, high-velocity network detection and response solution that's purpose-built to enable you to get in front of this transformation. Discover hidden network threats, automate security investigations, and optimize security workflows to stay a step ahead of attackers with Gigamon Threat Insight. Learn more at securityweekly.com/Gigamon.
Welcome back to Enterprise Security Weekly. Do you want to stay in the loop on all things Security Weekly? Of course you do. Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher. Subscribe to our YouTube channel, sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch, where we occasionally get rated, and it's very exciting. All right. This interview is sponsored by Eclipsium. You can learn more by visiting securityweekly.com/Eclipsium. Joining us today is John Loucaides, VP Federal Technology at Eclipsium, frequent Security Weekly host. I can't even remember if I've been on the same show with you, John, but I know I've watched you on several shows. I think maybe on Paul's Security Weekly. And this is one of my favorite topics, the often overlooked attack surface of device firmware. Welcome back to the show, John.
Thank you very much. Always a pleasure to be here, and I always have fun with all of you guys. So I'm very pleased to be, here with you, Adrian, today. So thanks.
You'll be hard pressed to stump John with firmware-related questions.
Oh, are we going to play Stump the Chump?
I was thinking
that'd be very funny.
And in our prep calls, we try and tune our interviews right for the audience. Yeah. We're here on Enterprise Security Weekly, but John, I get so nerdy, and that's when I ask all my questions, like John, how does EFI work? Yeah, we get really nerdy.
Right. There's always something new to learn about this space because it's also changing. And that's why you will actually succeed if we try that. And it will be hilarious for everyone.
Right. But what's also
try that sometime.
What's interesting too, we're kidding a little bit, but also things at the firmware level are meant to kind of be out of the user's purview, right? Because John and I were talking about how when you enable Microsoft updates and you do the other, I forget what Microsoft calls it, other driver updates. I'm John, are those always driver updates? Sometimes they're actually firmware updates because they've tried to take this away from the user because we don't want to have to worry about it until we do.
Magic, it's updated now. That's so cool. Mm-hmm. It sometimes works.
It's part of the problem in this space, right? Is this stuff has always been designed to, no, you don't have to worry about that. We'll take care of that behind the scenes. Except they don't a lot of the time.
Right.
Right.
And the tough part is that if you think about how your enterprise architecture is set up, you are expecting to manage certain things, and you may actually be under some contractual obligation to deal with certain kinds of issues in a timeline to always keep things up to date. And so you're expecting to be able to see a certain level of detail. But the premise of firmware was that you don't need to worry about that level of detail. But that's a fallacy. It's this idea that some software is different from other software and doesn't have the same problems that every other piece of software has. And that makes no sense, right? What's actually going on is that there's some set of software that we have chosen not to think about, and we call it firmware. And that firmware is something that's controlled almost entirely by a manufacturer, and you just don't get to see into it. It's a black box to you, and you assume that they're taking care of it, right? But you have no real visibility into that, and that's the problem. But if you really think about it, every one of us, everyone in the audience too, already knows about this problem. This isn't like some new weird thing that I just came up with yesterday. It's something that you knew about and has been in the back of your mind for a long time. And what we're starting to see is that people have been expressing that in various forms. We've seen now some studies from both Microsoft and HP that are showing over 80% of people either have experienced, in the case of the Microsoft study, a firmware attack, or in the case of the HP study, they're worried about it. They believe that the risk is significant to their organization. And why is that? You're kind of looking at, you just look around you and you're seeing all of these network devices, VPN concentrators being attacked, being exploited. And a lot of times you have no heads up. You have no warning. It's a 0 day for you. And, the manufacturer comes out with something, on Friday at 5:00. And now we're working holiday weekends just to get things patched.
John, I have a question for you. Do you own your own private island?
I would love to.
Right?
That's my goal in life.
And where I'm going with that is, if all these companies, like let's say they surveyed thousands of companies, know they have the problem and they did something about it, and maybe they bought your product, you might own your own private island. But I think where we are is all these companies
I was wondering where you were going with that.
All these companies know they have a problem to some varying degree, but most of them aren't doing really much about it, right?
That's right.
That's kind of where I feel like we're at.
I do feel like that's where we've been for a long time. I'm hoping that's changing. And in fact, frankly, that's my mission, right? Like that's the whole point of me doing this whole Eclipsium thing.
Right. And when you get your own private island, I'm angling for an invite. That's all.
I'm definitely, I want you to have the show there. Yes. We should totally just like take a weekend and just do this together. I'm in, totally. But like, we were, when I started out in this space, I was interested in it. Like it's an intellectual thing. I'm into hacking stuff. And I thought, dude, I can get underneath everything and just bypass all of it. And so I was interested, right? But the point is that you don't have to know all of that stuff. You don't have to get interested and geek out over all of these things. It should be something that you can manage with a process that is just like every other process you've got, right? That's the premise of Eclipsium. And it's really not rocket science, to be honest. It's sort of like, that thing you're doing with every other piece of software, you probably need to do it here too.
Yeah, and I also think that the interesting thing is when we as nerds like work with firmware, it's usually because of two reasons. One, we're trying to make something work as it's intended, and we got to do a firmware update to make that happen. Or we're trying to make something work as it's not intended, and we're either trying to hack it and get malware on it, or make that device do something, like I said, that wasn't intended. Like we hack firmware on routers and things like that to be able to put our own custom software on it.
That's all it is. You're right. And it's funny because it feels like it's some black art, right? Something that, nobody knows, and it's secret, and it's sort of special, but it's totally the same software stuff that you've seen everywhere else. Half of the devices that I've looked at is when I've gone down to it's just Linux. Yep. And it's some special build for maybe a PowerPC or an ARM or whatever. We've seen 1,000 of those. I mean, you've seen 1,000 of those, Paul.
It's not that mysterious, right?
It's not that mysterious, exactly. And if you want to go deeper, go for it. You go get the data sheet for that ARM SoC, right? Go look at what registers they're doing, figure out how it configures the board. It's going to be less mysterious than you think once you start figuring out what it's doing. Computers are just computers, right? Like they do the same stuff. There's a way to configure it. It either did or didn't do it right. There's some stuff that people usually forget, but that's actually what the problems sort of gravitate toward. And as we're starting to look at things like zero trust architectures, all that really means is that all those things that you were ignoring before, that you were just taking for granted, those are the trusted things. Well, you're trying to not trust them. You're trying to zero trust them, right? So a zero trust architecture, a lot of times is really about device security and being able to know a way to verify that this device is actually in its correct state.
Going back to where we start at the top of the interview, where these are processes and computing devices that we really shouldn't have to worry about, how prevalent is auto-updating some of these various firmware updates? And then, but like, you're not done, because Windows has auto-updating, but we still hack into Windows PCs. But I still feel like we're not quite there yet with firmware.
We're so not there yet. We're trying. I mean, like you did mention in the early part. At first, by the way, I thought that you were going to go back to geeking out, and we could do that. But the thing that you probably have seen before, and I know you mentioned it, Paul, is in Windows Update, you get that little optional updates, little drop down thing, and it can show you stuff. Sometimes you'll see a firmware update in there. That is cool. That's a huge monster step for this industry that we've never been doing before. Now we're starting. And it has all the sort of things that come with starting. And sometimes it's there, sometimes it's not. Sometimes it tells you to install the thing you just installed. Sometimes it's, not really the latest version. Okay, but it's better than we were. But notice that that's just the system firmware for running on Windows. On Linux, there's another project, and props to Richard Hughes if he's listening. LVFS is the Linux firmware updater, and they actually have one now, and it's a thing, and people use it, and it's actually built into a lot of the a lot of your distributions already. Very cool. But it has the same limitations. It's sort of like it's an opt-in. Some vendors participate with some models and not others. And so it's sort of a mess if you're looking at a large enterprise with a lot of systems, especially if they're not all the same system. Right. So this gets to be a struggle. And when we look at this, let's talk about patching, right? You can use those automatic update systems. But then if you manage a really production infrastructure that needs to be running, you start to worry about that. And you should, because that has broken, and it does break. So when that happens, you're going to be on the hook for another weekend to work through that and fix it. That sounds like just monumental risk. Yeah, and so what we've been doing is working with NIST. And NIST has a group inside of it, the NCCOE, the National Cyber Center of Excellence. And they're actually publishing these, what amount to how-to guides. I mean, you remember the old how-to guides and big text file and do this and this and this. They're actually naming these 1800 series publications where they're going to put all these products together, put it into a process, and actually explain to you how to set that up. And they have one on enterprise patching. Definitely would recommend for folks to take a look at that. Eclypsium's participating, and the premise of Eclypsium there is to get this firmware layer of stuff into the enterprise patching process, which it can be, but you do have to manage it.
Yeah, and where I think the struggle in the enterprise, from a somewhat nerdy perspective, but we started with operating system patches, right? So we got to get better at that, and largely we did. We got to get better at application I got to make sure the browser's up to date on everyone's computers, and we got better at that, arguably, over the years, right? But when you get down into, we've had to do this on the enterprise, and it's very similar, because the driver for your hardware that's associated with your operating system is different from your firmware updates. And now all four of these things have to be in line and work together. If I update the firmware, I got to make sure that the driver supports that, which the operating system has to support, which could impact the application. Any one of these things in the chain can break. Now you've got this matrix of four things you have to worry about in enterprise patching, which could be one of the reasons why people just sweeping it under the rug.
Yeah, and to add to that, for me, learning about firmware, I remember the first time I saw a talk on bad USB, where they're talking about doing malicious things with flash drive firmware. Just kind of opened my eyes, to the fact that these little guys have are basically computers with their own RAM, their own flash, their own CPU and stuff like that. But then it's one of those things like learning about microbes. You start seeing them everywhere, and it's a bit overwhelming. Like you learn that a tiny micro SD card has firmware on it, and the average monitor is an x86 PC, basically. And the microphone I'm talking through right now gets firmware updates like once a week. My Jabra headset and the little dongle that I use for my Jabra headset get firmware updates. So it becomes kind of overwhelming. And where I'm going with this is how do you prioritize with that? If I've got PCs and systems from different manufacturers, like the process for Dell is going to be different from Lenovo, which is different from how do I do it on my Macs? At least with the Macs, it all comes from one choke point, right? Like it all comes from Apple. But with some of these others, like they've got this really sketchy software they want you to use to do the firmware update that sometimes have vulnerabilities in them themselves.
It's a great problem that Eclipsium solves for you. Actually, right? I mean,
what was that?
I said it's a great problem. What Adrian just laid out as a problem statement is one of the reasons why you exist as a company at Eclipsium, right?
Absolutely. And let me take that in a couple pieces, because the reality is that is almost an intractable problem. Just like you've laid it out, it is that complicated and then some, because every time you dig a little bit deeper, you're going to find some more of those things, right? Mm-hmm. Take a look at your motherboard and just stop. Like, it's game over. There's so many of these things on one board, and they all are running an operating system, and they all got applications on. Okay, I don't even want to know. That's actually the thing that has caused so many people to just think of firmware as an unsolvable problem. And that is exactly why we exist. We exist to be like, okay, no, it's not unsolvable. We're going to solve it, but we're not going to solve it all in one step. There's no silver bullet, none of that. Yes, we're going to have limitations too, but the reality is it comes back to that prioritization. And that was a great question, because how do you prioritize? Well, you could do it a lot of ways. If I were on some, high assurance system evaluation, I would be doing more of a failure analysis and looking at which failure modes actually are the most catastrophic. All right. And sort of prioritize the level of effort against how bad the outcome is. Okay, great. But that works for the very small scope of that specific thing. And not even that thing in this particular context where it's being used. If you have the ability to do that in your organization, awesome. That's puts you ahead of the game a lot. But usually, even in those cases, you have something that's around that. That's more of a regular IT problem. You have a normal enterprise with a normal computer. And at some point, it's going to devolve into what everyone else is doing. And that is where this blows up. That's where you can't really make these very specific priorities that are tailored to a very specific use case and mission. So in the broader world, we have to sort of look at a couple of sort of quick and dirty things. One of those is to look at what are attackers actually doing. And that involves keeping up with research. We kind of got a head start on that by being part of the research community ourselves, and that's why we sort of started all of this. But we have to keep up with it, and the research kind of moves into different areas, and as they move, it's usually followed by somebody who actually is going to do something malicious. So you start and you research something, and you learn about it, and then other people get the idea, hey, I should learn about that too. UEFI work this way. If you start to look at what's actually getting exploited, you'll see UEFI in there, but you're also going to see every single network device firmware, and like DHS, CISA, and some of these partner agencies across the world released a joint publication on the most routinely exploited CVEs for 2020, and then again in 2021. Yeah. Look at that. Look at 2020. How many of those were devices? 4. And in 2021, how many? 11. So it was 4 out of 12 and 11 out of 16. And you're really seeing an explosion of this sort of stuff. Why? For the obvious reasons that we all have been sort of dancing around. You're not looking at it. You don't have control of it. It's going to be broken. And so you end up in those bad situations again. So what Eclipsium is really doing is trying to go after those things that people can get to. They know how to get to them. They're not an insane amount of work to go figure out. And we're going to get those under control first. And then we're going to go get the next one and the next one and the next one. And iteratively, we're going to cover almost everything. Yeah, there'll be a limit at some point, but that's the premise for Eclipsium. And it's got to work in a way that's not specific to one device, because we're going to cover all the manufacturers. And that is kind of the fun part for me as a researcher, but it's this concept of a device profile. It's this idea that I don't need to know everything about everything. I need to know when it's behaving normally, and I need to find that abnormality when it happens.
But it also sounds like, John, that UEFI is a good place to start. I mean, even the acronym is universal, right? Which
yes,
conceivably, right? The process for controlling, placing controls around that should also be somewhat universal.
It's universal, and it's also underneath everything. It's the foundation upon which other things are going to be built. So an operating system security is dependent on what UEFI does. Mm-hmm. If UEFI fails to configure the platform properly, then the operating system cannot use the hardware features the way they were expecting to. Mm-hmm. So absolutely, it's a good place to start. It happens to actually have a standard, which also helps. Yep. So those sort of things make it work. There's also, it is
an operating. Essentially, UEFI is an operating system for all intents and purposes, right?
If you go to like a textbook definition, it's totally doing all those things, right? They're managing different things that execute modules. Mm-hmm. They're interfacing and creating an abstraction between the hardware. They just don't use all of the same features that normal operating systems use. They don't have memory protection usually. Mm-hmm. They don't, try to. Well, funny thing, it used to be that they didn't go and like create network connections, but that's not true anymore. Right. We had this recent BIOS disconnect thing you probably saw. Mm-hmm. They're actually installing firmware updates by going out to the internet, getting the update from the manufacturer's server, downloading it and installing it. Great, until you have remote code execution in that process.
Right.
But that's where we're heading, and we're adding features, so it's basically becoming more and more of an operating system.
Yeah. And what I find a nerdy side note on that is the monitor, mouse, and keyboard is sometimes not your interface to the UEFI system. The boards and hardware give the user some telemetry even before the system will actually recognize those other input and output devices.
Absolutely. And there's this whole sections of, and this is why UEFI is a nice starting point, because it's got a standard, because it's been around for a while, because it's in almost everything. Mm-hmm. You can now make these pretty accurate works on most devices statements about like, there's a certain time interval where up until in this phase of the boot, there are certain things that are expected, mm-hmm. certain things that are available. After this phase, they're supposed to be locked. After this phase, there's supposed to be different things that are available that you can depend on. And so that's nice, because now you can go and check stuff like that. And you can start to say, it actually was supposed to work that way.
And there's, sorry, go ahead.
Question for you. Do you do the actual, so one frustration of mine, I'm currently, me and Paul are with Security Weekly Labs are doing network vulnerability scanning testing. And a lot of these scanners don't correctly identify some of these devices. For example, my network devices, every major scanner out there identifies as Debian 7. And I'm sure there are some components of Debian 7 in there, but this is a device where like you can get the manufacturer name, from the MAC address. There's a proprietary service that if you query it, it will tell you exactly what model device it is.
Web interface.
It's got a web interface. Like there's 47 different ways to tell that this is not just a Debian server running on x86 or something like that. And it's so frustrating. So, I saw that you do have your own scanner product. Like, do you help with that device identification piece that seems to be so hard?
Actually, yes. Now, again, there's limits. We can't do everything under the sun. But what we did is, again, back to that prioritization, we focused in on those routinely exploited CVEs and those devices. And so we tried to get a profile for those things that are commonly exploited first. And when we do what amounts to a network fingerprint of those devices, we will try to actually identify enough information that we not only identify the device, but we also identify if it's in the vulnerable sort of version or configuration. And sometimes that's because we can scrape stuff and pull version numbers out. Sometimes that's more of a behavioral characteristics where you interact with it in a certain way and you know that it's version XYZ because they changed that after such and such version, right? And so a lot of these are more what you're talking about, where there are more tricks to it than just, the Nmap thing with, fingerprinting.
Right.
It gives you back Debian 7 for everything.
Yeah. Because I mean, so many things are running embedded Linux these days that's just not a useful technique anymore.
Useless. You're right.
Yeah.
You're right. And so here's the deal. Eclipsium is trying to actually fit into your organizational process. If you want to do research like what I like to do and sort of play around with, Paul and I will totally go to town on geeking out over it. But you get tools like, open source Nmap, chipsec for the firmware and hardware stuff on an x86. That's all cool, but it's hard to fit that into a process. You're going to need like people and experts to actually go figure out what that's doing and what that implies in your process. What are you going to do about that? The reason for something like Eclipsium is to actually take that expertise and amortize it over all of our customers. You sort of do that once and you start to say, no, here's how it fits into the process. It goes like this. So run the network scan, find out what's around you, do that periodically. And every time you start connecting to one of these, vulnerable VPNs, we're going to let you know about that. And if there's something anywhere in your environment that happens to be one of these top, 15 or whatever CVEs, we're going to let you know about that. There's also going to be a profiling of your device that says, is your device behaving properly? And when it's interacting with all those other devices, we're going to know that this device communicates with that device, and both of them are operating normally or not. So that's where you actually are talking about multiple processes in the organization. One of them is vulnerability management. We started off talking about patch management, and that's half of it. But the other half of it is incident response. It's like, I know there will be risks in the firmware of all of these devices. And no matter what I do, there will still be some left over. When something goes wrong, how are you going to know? And what are you going to do about it? That's the other side of what we're trying to handle.
Yeah, there's a lot of important pieces you're handling there. But, if I were to pick one that's most important, I think it is that prioritization piece. And I love that you mentioned CISA and how they're kind of floating up these top 10, top 20 CVEs, because when I looked at that, it wasn't stuff that it wasn't stuff that I recognized or would have expected, even with the stuff that I, was familiar with. So I love that they're doing that, because they've got some insight that we just don't see in our normal day-to-day news cycles and jobs. And I didn't know until the other day that Mirai was still a thing. And you look at the list of devices that make up.
That first happened.
Yeah,
what?
I know.
Still totally a thing. I mean, there's all variants.
It's setting new records.
Well, now there's a million.
It's setting new records for attacks. And you look at the list of devices that make that thing up, And I can guarantee you wouldn't guess 90% of them.
So what's
or
funny?
maybe haven't even heard of them.
Mm.
Yeah.
Well, we did some research on some stuff like that too, and it's actually, I know exactly what you're talking about, because every time you go looking at what constitutes some of these botnets, you end up learning about new models of random things that somebody put out at some point in your life that you just totally missed. But that's the interesting thing that I think as a researcher, you need to build on other people's work, and you start to think of this stuff as sort of compounding. Well, that's what the attackers did too, right? Everybody built on top of Mirai because it was successful. It worked, and it worked well. And now you build on top of that, and you did some more, and you were more successful, or at least as successful. So why can't we do that on the defense side too? And there are some interesting lessons that you can learn as a defender, especially if you're trying to identify what's out there from the way that Mirai propagated. Mm. And so you can build those techniques into your network scanner too. And now even if it's not a specific model and version, that it's using a default password, right? And that it's configured stupidly, if you will, right?
Could we call that the low-hanging fruit approach?
The low-hanging fruit approach is not a bad start, right? And especially when we moved to a distributed working from home model, and you got out of the possibility of managing everything around you. That wasn't even a thing. So this is sort of the idea, is that when we're profiling a device as Eclipsium, we want to go deep into that device because that's our thing, that's the firmware. But what we wanted to do is learn from what's going on around us, look at stuff like these CISA alerts, and say, well, okay, I should be looking around my device too, and I should be saying, is any of that around me? I really want to know about that if it's true,
Yeah. Well, John, I'm deeply jealous of the research you get to do, and very much looking forward to the next time we get to chat again. It seems like, this could go on for quite a while, but thank you so much for joining us on Enterprise Security Weekly today.
Thank you for having me. Take a look at our website for an upcoming blog on just this topic, where we're going to be talking about those CISA alerts and how much this is affecting device firmware. So I'm always very happy to be on your show. So thank you again for having me.
Thanks, John.
Absolutely. Make sure you visit securityweekly.com/Eclipsium to learn more. And of course, their blog, as John mentioned, some good stuff there. And next up, we go over the latest enterprise security news. So stay tuned.